Black holes are cosmic coffins where massive stars buried themselves after their violent demise. Stars after dying leave their footprints, and black holes are one of the final souvenirs of the Death Star, including neutron star, white dwarf, etc. In order to give birth to a black hole, a massive star has to die in the first place. Black holes are born literally inside the belly of a gigantic star having a mass of more than 9 suns. To understand the phenomena, we need to know how stars work. A star is nothing but a delicate balance between inward gravitational pull and outward pressure generated by the nuclear fusion process. This stable state is called hydrostatic equilibrium, and it lasts millions of years in a massive star. The more massive the star, the less its lifespan. The tremendous heat of a star is a result of the nuclear fusion reaction where hydrogen atoms fuse to form helium. When atoms fuse, some mass is lost, which is converted into energy, as described in the famous Einstein equation E is equal to mc square, where E is the energy, m is the mass, and c is the speed of light. When hydrogen atoms fuse to form helium, temperature rises, which increases the atom's kinetic energy, resulting in the fusion of helium into carbon. The conversion of elements further increases the temperature, which goes on fusing carbon to oxygen, oxygen to neon, neon to magnesium, magnesium to silicon, and eventually to iron in its innermost layer. Once the star manufactures iron in its core, it writes its own death sentence, because unlike other elements, fusing iron consumes energy instead of producing. This results in a sudden decrease in outer pressure, and ultimately gravity wins the battle. Stars suddenly collapse into itself as there is no outer pressure left to counter the inward gravitational pull. The collapse is so fast that it rebounds and blows up inside out, creating one of the most cataclysmic events humans have ever witnessed. This extreme explosion is called supernova. Just imagine the explosion so tremendous that it can outshine the whole galaxy. But even the explosion of this scale is unable to wipe out the star entirely. After the blast, a highly compressed core of the star is left, whose mass decides its fate, whether it will become a neutron star or a black hole. If the core exceeds the mass of 1.4 Sun, it collapses again even to the atomic level. At this stage, even the space between electrons and protons is crushed by gravity, but the compression finally stops due to outward electron degeneracy pressure, giving birth to a neutron star. On the other hand, if the leftover core mass exceeds 2 to 3 solar mass, then even the electron degeneracy pressure and nuclear forces bow down to its enormous gravity. The star continues to collapse into an infinitesimal point, giving birth to a black hole. Black holes are one of the most bizarre objects in space, having gravity so strong that it consumes everything water comes inside its gravitational influence. Even light can't escape from its immense gravity, making it look pitch black, hence the name black hole. As space is also black, these bizarre creatures can easily hide in plain sight, but its monstrous gravitational effect reveals its identity. For example, stellar black hole V404 Cygni was discovered indirectly by observing its companion star V404 Cygni b. Strangely, this K-type star was seen circling an invisible object that was found ejecting X-rays out in space. The star and the black hole are orbiting each other in just 0.56 hours. By analyzing the gravitational force, the mass of the mysterious object is estimated to be equivalent to 9 suns. A stupendous gravity lures the star material and creates an accretion disk. The matter around the event horizon rotates very fast, which generates tremendous heat due to friction, resulting in the eruption of X-rays. After observation, scientists conclude that the only candidate with this colossal gravity in such a tiny region that pulls neighboring star matter toward itself and shoots X-rays is nothing but a black hole. These black holes that are born from the collapse of a massive star and have a solar mass of up to 2 digits are categorized as stellar mass black holes. Singularity is the infinitesimal point having infinite density at the center of the black hole. The event horizon is the point of no return. Any matter and radiation which passes the event horizon ultimately falls into the singularity and becomes part of the black hole. As matter superheated gas dust orbits at high speed at the boundary of the event horizon, it creates a flattened disk called an accretion disk. Due to extreme orbital momentum and friction, it generates tremendous heat which helps them to show their presence by producing jets of electromagnetic radiations including X-rays, infrared, optical and radio waves. These X-ray emissions are detected with the help of Chandra X-ray Observatory, which helps scientists discover and pinpoint a black hole and other super hot regions of the universe. The distance from singularity to the event horizon is called Schwarzschild radius, named after German astronomer Karl Schwarzschild. We can calculate the Schwarzschild radius of any space object by this formula 2gm divided by c square, where g is the gravitational constant, m is the object mass, and c is the speed of light. Whatever comes inside the event horizon is consumed and its mass adds up to the mass of the black hole. This results in more gravitational influence and an increase in the Schwarzschild radius. The more massive the black hole, the bigger its event horizon is. You can convert any object into a black hole by compressing it to its Schwarzschild radius. For instance, if the sun squeezes itself to a diameter of 3 km, it will transform into a black hole. Similarly, to convert Earth into a black hole, we have to compress it to the size of 1.6 cm. I hope you guys find this video informative. Stay in touch and take care. I will see you next time. Thanks for watching.